Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group in Brisbane, and we concentrate on helping people get into Python and also people looking at learning machine learning. We present online most weeks on Wednesdays, and once a month we do it in person at Amazon in George Street in Brisbane. There won't be a session next week because it's a public holiday in Brisbane for the Eka show. The first week of every month we try to do target absolute beginners. So if you've never seen Python before, this is a session for you. We're going to be doing it using Google Colab, so you don't need to have Python even installed on your computer. You just need a web browser and preferably a Google account, but I suspect you could get by without that as well. Alright, now this is a online, it's a live stream, and so the advantage of that is that you can ask questions. So you can ask in Google Chat. I'll be watching this YouTube chat that's in YouTube, but we'll also got a Slack channel, so we've got the Learning to Code channel here. So if you want to put your questions in here, you can see questions from previous sessions people have put in there, and Slack doesn't get censored as much as Google, so you might have a bit more luck getting any questions through. Alright, now to start we're going to use Google Colab, and I've got the meetup event description here, but even just the YouTube description down below what you're currently watching, we'll have a link to Google Colab, colab.research.google.com, and we've got a special link. So if you click on that link, and that'll open up a new tab for you, and I've shared this notebook so you can follow along and the script. And this is a great way of learning Python because you can just run a few lines of code at a time, see what it does, make changes, run them again, whatever you like. Now you'll see it says here changes will not be saved. So the first thing you need to do is copy it to your own Google Drive, and then you'll be able to save changes that you've made, because at the moment you're just using a notebook that I've set up. So I'll copy that, and I'll copy this to this Google account that I'm currently in. We'll open that in a new tab. Okay. It's telling me I'm not saving any outputs, and I do that just so that you get a fresh slate when you start it. Release notes, we can close that up here on the right, so I'll just close those release notes. Now the first thing we want to do is connect, so click on connect, and that'll just save a bit of time later, and Google will set up a virtual private server just for you, and they'll give you some RAM and some storage space in which you can run the Python for this code. Now to run, this is a Jupyter notebook, and Jupyter notebooks are made up of cells, and you can see there's a cell here, it's got a rectangle all the way around it, and that's called a text cell because I've got formatted text in it. I've got a few links in there to have a look at, like a link to the meetup page. We've got a link to our GitHub site, and on GitHub we store all our old sessions, so if you want to go back through our old sessions you can find all the ones that I've done, and the ones that we've done online, they'll include a link to the YouTube online, and it'll also have a link to any Colab notebooks that were created for those sessions. So this session we're going to be looking at mainly looking at three Python data types: the list, the tuple, and the dict. So lists and tuples are just ways of collecting data and getting them out in order, and a dict is a dictionary, so it's mapping, so you can put keys on it. But anyway, we'll get into this. If you're just really getting started and never seen it before, you might want to look at our Meetup 191. And this will be like the second one after it. So I'll throw in a few terms that we've done in the other one, but I'm certainly happy to take any questions because we've done this before, and really the benefit of this is the live stream and that you can ask questions that are on your mind. It doesn't even matter if it's off topic. Okay, so to use Google Colab, you just type into one of the cells. So you can see this is another text cell here. I just clicked on it and now you see the rectangle around that. Here's another one here. And then down here we've got what are called code cells. And this is where we can type in some Python code. And if you see, if I hover in between any of these two cells, it lets me add in another code cell or another text cell. And you can do that tonight, even as you're watching. If you think, oh, I didn't really understand that, what will happen if I do this? Just fire up a code cell and type the code in and run it, and see what it does. It's a great way to learn. So to run it, you just see it's got a play button. When I hover over the left-hand edge of the cell, and you click on that play button, or in this case type Control Enter, and it will run the cell for you. So I've typed in 3 lines of code here. These are Python statements. The first one starts with this hash key, and Colab has colored it all in green, and that's because it's a comment, so it just doesn't do anything. It's really there for your benefit. So you put comments in code to remind yourself what you were trying to do when you wrote the code in the first place, and so it'll tell you or anyone else reading your code what the code is trying to do. So I've put a comment here. We're going to define a list with square brackets and a comma separated list of any data types. So here we go. We've created a variable name. I've called it LST, and on the left hand side of an equal sign, and on the right hand side I've put what I want the value to assign to it. So I put square brackets. These are the square brackets, and then a bunch of values in between separated by commas. And I've got this one here is a string because I've enclosed it in quotes. This one's an integer because it's a number not in quotes, and it's got no decimal point. This one's a floating point number, where in Python we call them floats. So it's got a decimal point, and it's stored in binary, which is something that we won't need to know this session. This one here, 3, is actually a string because it's enclosed in double quotes. So even though it's a number, it'll be saved as a string in Python. And so we put all these different data types together, separated by commas inside the square brackets, and we've got a list. And the reason I didn't call my variable name list, L-I-S-T, is because Python has a function called list, a built-in function to create lists. And if you call a variable list, you'll override the built-in function name, and then you won't be able to call it. So just be aware of that. Don't call your lists list. Now I'm going to run it, and we'll see what we get. So we've created a list of these 7 pieces of data. We've stored them in a variable called lst, and then we've displayed them using the print command. And it displays it pretty much how it looks when we created it. It's used single quotes, double quotes. You can use either in Python. They mean the same thing. You just need to match them. So if you start with a single quote, you end with a single quote. Start with a double quote, you end with a double quote. Alright, now you can refer to individual items within your list using an index. So you have the name of your list, a couple of square brackets, and inside them you put the number that you want to of the item that you want to display. And there's 0 index, so the first one is 0. So if we say what's in list 0, it tells me the value is 6. Now you see here, I haven't even put the print statement here, but Google Colab, this is a shortcut for Google Colab. It won't work in normal Python. In normal Python you'd have to put a print statement there, but this is an interactive Python in Google Colab, so that this shortcut means that the last line, if you just put a variable or an expression, it'll evaluate it and display the result. And the result here is 6 because it's the 0th element in this list. Now lists can also refer to elements starting from the right hand end. In this case we started from the left hand end, so we said what is 0 in from the left hand end? It was 6. But we can also go -2 back from the right hand end, and let's see what that'll display. So it displays 1, so we come from the right hand end and we go back and there's 1. Alright. Now there's built-in functions. len is a built-in function, and you can add find the length of different variables of different types, but length on a list will actually tell you how many elements are in the list. So if we run len on list, it tells us there are 7 elements, which is what we counted before. So I hope you're following along, just pressing the play button as you go, and seeing these same results come up on your screen. If you want to try different things, click the code button, type in some extra code, and see what comes out. Alright, now the indexing is pretty powerful. We can actually slice a list, which means we can put in a starting value and a finishing value, and it'll give us everything in between. So in this case we'll start at 2 and it'll go up 2 but not include the value at 5. And it's easy to know how many elements you're going to get returned. It's just 5 minus 2, you're going to get 3 elements, and we did 4, 3, 2. Okay, now some people get a little bit confused by this thing saying go up to but not including the finishing value. And so the way I like to think of it, I've just used a bit of ASCII layout here. So I've put in, this is my list, and I've put in here what the indexes are. So 0, 1, 2, and they really refer to like the comma positions. So if you refer to 0, you get this one here. If you refer to 2, you get this one here, even though it's the third one in, as you might count them. But we count 0, 1, 2. So if you want to have a slice from 2 to 5, the only things that are included in that slice are 4.0, string 3, and TWO. Similarly, the same thing works with negative indices. So you could say I wanted to go give me a list from -6 to -3, and it would give you those 3 there. So let's just try that. Click in a code, create a new code cell, type in the list, open the square brackets, which it's done, and we want to go from -6 to -3, and we want to put a colon in there. And we get those values 5, 4, 3, which I predicted. Alright, let's have a look at our original list, as you remember. And now we want to assign an item at a particular index. So at the moment, at index 2, we've got 4.0, and we want to replace it with the string FOUR. So we can do that using the equal sign. That just says assign to that value, that index, this value, and then we'll have a look at what the list looks like after we do that. And there it is. We've just replaced 4.0 with FOUR. You can delete an element from the list using the del keyword. So del is one of Python keywords. As you can see, it's coming in here as a different color. And the fourth element, element 4, 0, 1, 2, 3, 4 is 2 here. So let's delete that and see what our list now looks like. And you can see TWO is missing. If we want to add another item to the end, we can use append. And I've decided to add a different data type again. I'm adding 1J. So J is in Python is a square root of -1. Python likes to support complex numbers, so if you've got any experience with complex numbers, that's what it looks like, and you just type them in using the J letter. And so there we go, there's our list, and it's got a value of 1J in it. So if you want to just check what 1J times 1J equals, it equals -1 plus 0J. So that's because J is the square root of -1. So you multiply it by itself and you will get -1. I can't just type J times J because it'll think I'm referring to a variable called J. Okay, so that's it for lists for the moment. Let's have another one. Look at another one called tuple. Now a tuple is just like a list, except it's immutable, which means it can't be changed in place. Remember how we changed 4.0 to be FOUR, and how we appended something to an existing list? Well, we can only do that because lists are mutable. Alright, so rather than using square brackets, we just use parentheses here, and let's print our tuple. 6543210 looks the same, except it's just got the parentheses here. Now from a coding point of view, you're going to find your code is much more reliable, is more reliable if you use immutable variables. So only use mutable ones if you actually need that mutable property. Otherwise use immutable and you'll avoid some really subtle programming bugs that can creep into your code. They don't happen a lot, but when they do, they take a while to find. Okay. Now to refer to, so I'm suggesting use tuples rather than lists if you can, but if you need a list capability, then use lists for sure, because they're there and they're a very useful data type. So let's look at the 0th number in a tuple, and there it is. It's a 6 SIX. So here's our first challenge. What is something you can do in a list that you can't do with a tuple? So let's go through some of the things that we've done, and I'm going to print results here using F strings. So just to show you how an F string works, we've got a string here which has got double quotes around it. Could be single quotes, double quotes, doesn't matter. But I put an F out the front to make it an F string, and what that means is anytime it finds curly braces inside the string, it'll evaluate that expression. And Google Colab's even color-coded it for me and said, yep, there's some green curly braces and there's an expression in there. So I'll make that color black to show you that it's actually going to be executed as code rather than this, which is just all text in a string. So if I run this code, I get TPL equals, just here, TPL equals, and then rather than printing TPL, it evaluates it out to this and shows that. Alright, so now we've got the idea of how F strings work, and I'll just put in a lot of expressions here into the curly braces, and that'll evaluate them, but it'll display it in a nice string, nice bit of text, so that we can, it's easier to read the results. So let's run that. So tuple TPL 0 returns SIX, TPL 1 returns 5. So these are all pretty much the same as we did with the lists. We can see it does negative indices as well, so they all work. Alright, let's have a look at slicing. So 2 to 5, let's have a look what that comes out as. 2 to 5 gives us 432, just like before. So I've done a couple of extra different things you can do with slicing, and these things work with lists as well, is putting in the colon but not specifying the first value, and that's just the same as if I put a 0 there. So I could have said 0:4, or I'll just say :4, and I'll get the same answer, 6543. This one's probably more useful, is putting in a colon but not specifying the end value, because you can't actually put in a slice. You can't put a number there that will be the end value. So I guess you could put a number bigger than the size of the list, but often you don't know what the size of the list is, you just know you want to go right to the end, and so that's where this is extremely useful. So in this case, 3 to the end gives us 3210. Okay, so here's an interesting one. We've got 2 colons in our slice. So we specified the start value of 1. The next value, which isn't specified, is the end value, just like it was up here. So that basically says I want to go to the end of my tuple. And then I'll put another colon, and I'll say this third value in the slice is how much I want to go up in. I want to go up in steps of 2. And so I can say tuple 1::2 will give me every second element starting from number 1, which is 5, and then 3, 1, and going right to the end. Okay, I can even use negative steps, which says because that's a negative value there, when it looks at start and stop, it knows it's got to start at the right hand end because we're using a negative number, and so leaving it blank, it just means the right hand end. And I want to come back to 1 but not go all the way to 1, so I'll stop 1 before it, and that's, you can see, it returns in the reverse order. So it's a quick way to reverse a list or a tuple around. And yeah, you could just do : -1 and you'll get a reverse of the list. Now I just had a comment. Good point about tuples. I would probably default to using list when I could have used a tuple instead. Yes. It's a point that people don't talk about much, but there's a lot of people talk about the benefits of using immutable variables, but then when it comes to tuples and lists, they don't actually say that's where you'd use tuples over lists. Alright, let's have a look at some of the built-in functions and operators. So len is the built-in one we tried before. It worked on a list and it also works on a tuple. You can add, you can use the plus operator on tuples and lists. I didn't show it above on lists, but you can try that yourself. So for example, tuple plus tuple returns that and that. So it's just all the elements concatenated into one big tuple. You can even use multiply, 3 times tuple, and you can even do tuple times 3 or TPL times 3, and you'll get 21 elements. But if you try to do TPL plus LST, which is a tuple plus a list, you'll get an error. Can only concatenate tuples, not lists, to a tuple. All right. Now I didn't use curly braces in this one, so it's not evaluating that expression. But if you want to test that, open up a code cell and type it in, and there you go. Tuple plus list. Let's try the other way around. List plus tuple. And the error message is slightly different, but it means the same thing. And the other thing we're going to try, let's try list times 3. We hadn't tried that before, and there we go. It evaluates it 3 times. Okay, so let's try some assignment operators here. So I don't like having exceptions, errors in my code in the Google Colab, because some people like to just press play and run all. and if there's any exceptions, it'll stop at that point. So I comment them out and just say what's going to happen, but you can uncomment them to run it. So let's try the first one, TPL2 equals F, and that gives us the error as expected. So we can't assign a value to an element in a tuple because it's immutable. Similarly, using negative indices, that's also not going to work. And similarly, deleting doesn't work either. Okay, so that's what doesn't work. I'll show you another thing that does work. This works for lists as well. It's using the unpack operator. So when you're calling a function, this is a bit more advanced, so if you're an absolute beginner, don't worry about this. But if you're calling a function, you provide arguments to the function, like the print function, separated by commas. But if you've got a list or a tuple, you can put an asterisk out the front and it will expand it out as though we'd put in all those elements as separate arguments to this function, as just positional arguments they call them. So here we go. If I say print using unpack operator star tuple, that's like I put in using unpack operator, comma, SIX, comma, 5, comma, 4.0, comma, 3, comma, 2, comma, 1, comma, 0. And that's what the print statement will do if it got those parameters. So that's the unpack operator, and I'm just bringing it up mainly because the first time you see it, you go, what is going on there? I don't know what times TPL means if I've got a tuple. And that took me a while to find out when I was learning Python. But you may not want to use it until one day you'll discover that there are good times when to use that feature. Alright, now sometimes you want to convert a tuple to a list, and you can just use the list function that I mentioned before. It's a built-in function. And so I'm now displaying what list from tuple is. That's the name of my variable. That could be anything. The important thing here is that I use the word list in parentheses, which means I'm calling a function, and the argument to the function was TPL. And that gave me what looks like our tuple, but it's now got square brackets around it, meaning it's a list. And I could find the type of that as well. So there's another built-in function called type. And it'll tell me it's a list. Similarly, if I want to convert back, then I can just call the function tuple. And this is really most Python data types. You can convert something to that data type just by using the name of the data type and parentheses and provide the argument that's going to populate it. Alright, now I want to look at a few more features of lists and tuples, but we're going to need to know a little bit about programming to start with. So I'm going to write a little program here that rolls a die that returns a number between 1 and 6, and I'm just using the built-in random library and the randint function to give me a number between 1 and 6. And this is a rare function in Python because it goes from 1 up to and including 6 in this case. So the inclusive bit is where it's very rare, and so the more Pythonic name is one called randrange, and if you say randrange 6, it'll go up to it'll return an integer between 0 and 6 exclusive, even though I've written here 0 and 5 inclusive. Alright, so this is just particularly good for rolling a die. And I'm going to check that the die roll, so they give me an integer. I'm going to use this operator here, which says what's the remainder after divided by 2. So that's called the modulo operator. And if it's 0, then I know I've got an even number, and if otherwise it must be an odd number. So let's just run it and see what I get. You rolled 5, which is odd. You rolled 6, which is even. So it seems to be working. 4 is even. Yep. Okay, so we want to roll 2 dice and report whether the first die rolls a greater number than the second. So I might just go straight to the solution here because mine's not going to be any different to that. So I've used a list, and once again, here's a good spot. I could have used a tuple for that. I'm not changing that at all. So I'll rewrite this using a tuple. In fact, all I have to do is change that. And it's going to have 2 elements separated by a comma, and the first one's going to be just by calling randint, and the second one's calling randint. And then I'm going to display what I rolled, and I'm going to use a feature of the print function which says don't put a new line at the end of the line. I'm going to say I just want to end with a space, not a new line. And then I can do another print function later which will be on the same line, and I can compare, is dice roll 0 greater than 1, less than 1, or are they both equal? So I'm using the if statement to do this. If, and then colon, and so I've got a condition in my if statement, and then after the colon I indent the code. The convention is 4 spaces. I indent it 4 spaces. If you're using Colab, it might default to 2. So if you try typing it and press a tab, it'll default to 2, but that'll work as well. So 2 spaces or 4 spaces, and then everything that's indented is included in that code block. And the way that it knows that we finished the code block is the next bit of code that's not indented. And this is where Python's different to pretty much every other language. It's using indentation to work out where your code blocks are. So I've got one line that's run if the if is true, otherwise, else if. I check another condition. If that one's true, and of course to do this one, the first one must have been false, I run this code block, and then I end the indentation, and I have a final code block for all the other cases. So I just say else. I don't need a condition because it's just going to be everything else that I can display, and in this case we're going to say they are both equal. So you rolled 3 and a 2. Your first roll is greater than the second roll, and that's correct. So let's run it again. 4, 1, still greater. 5, 6, first roll is less than the second roll. Let's see if we get a double. 5, 5, they are both equal. So our code works. All right. So challenge 3. For an element of tuples, say whether string, int, or other. So you can check the type of an element by using this function, type of something equals a string, or you can use is instance string. So type is used when you want an exact match of the class. Is instance is used if you want a class or subclasses. So is instance is probably normally what you would want to do, but sometimes you are interested in knowing whether it's an exact match. So let's write this. So let's just say index equals 3, and we'll go if is instance, And I'm going to look in my tuple at the value with index 3, and I want to see if it's a string. So I can just type str and it knows that that's a data type. And now I press colon, and then when I press return, you see how Google automatically indented me because it knows that I've got to do a code block because I've put a colon on the end of the previous line. Print, and I'm going to say, I'm going to do an f string. Equals a string. Let's say is a string, and let's put this in curly braces. Alright, and that's the end of my code block, so I'll go press backspace so that I can do another part of my if statement in start a new code block, and I'll do an else if, because what are we doing? We're doing string int or other. There we go. That's going to be pretty much the same. And then I'll just do an else to catch everything else. Once again, it indents automatically for me. Alright, 3 is a string. How about that? 3 is 3. So let's try 4. So the value at index 4 is TWO, and that's a string. 1 is a string. Let's try at the beginning. 4 is something else, so it's not an integer because it's 4.0. So it's a float. But 5 is an integer. Okay, so let's check out the solution. So the solution used type rather than is instance, and equals and what it's going to be equal to. So we're doing exact matches here. And we're going to loop through everything in the tuple. So this is a really useful feature of lists and tuples, is that you can use them in a for loop as the value that gets iterated over. So a for loop means do this bit of code several times, and each time going through the loop, take the variable name that we've put here, which is a, and assign it to the next value in our tuple. So we can see if we hover over tuple, it tells us we've got 7 items there, SIX 5, 4, 3. And so the first time through this list, A will have the value SIX. The second time through, it'll have the value 5. Next time through, 4.0. Okay, then we can look at what the type of A is. If it's a string, we're typing str. If it's an int, we're typing int. And if it's something else, we're typing other. And we're also displaying the type here, so we can see what it actually is. So that was a for loop with the just a variable name here in the for loop. We can actually just type a tuple straight into the for loop. So for number in 321, print number. And there we go. And you can see we've got a colon at the end of the for loop and a code block, so it knows everything in that code block is what's repeated, which is just one line in this case. And we're diverging a bit here from lists and tuples, but anyway, let's keep going. There are other sorts of loops. One's a while loop is basically continue doing this code block while this condition is true. So you want to make sure that something in the code block is going to change one of the variables in that condition, otherwise you'll have an infinite loop. So we're continuing until while counter is less than 10. So once counter gets to 10, it's going to stop. And fortunately, in our loop, we've got this counter plus equals 1, which means we're going to increment counter by 1 every time we go through the loop. Anything else special in here? I've used a list, and let's use a tuple. And there we go, let's run that. You rolled 3, 4, and it's given us that. So we've got our counter number down here. When it got to 10, it didn't run anymore. So I just threw that in so you can see how you work with loops. Alright, challenge 4. Write a program which prints every number from 0 to 20 as digits and its name in words as well, as well as whether it is even or odd. Okay. So we're going to do a loop, and it's for I is going to go from 0 to 20. So one way of doing it is type them in all like this, and that'll probably do for now. There's my tuple. I is going to have each of those values each time, and print I. So let's run that. And there we go. 0, 1, 2, 3, 4, 10. That's good. Now that's in digits, but I want its names as well. So fortunately, we've created this tuple here. Make sure you run this cell if you want to run this. Otherwise, it won't get assigned. It won't get assigned. And that'll assign all these values into a tuple called numbers. And now I can use that in my print statement. And it's a tuple, so I can index it just with I. And now I've got digit 0, name 0, digit 1, name 1, all the way up. So I've got digits 1, 0, name 10. And if you did all the way up to 20, you get all the way up to 20 there. Now we also want to check if it's even or odd. So let's go to check whether it's odd, even, we just say if I%2 equals 0, then we know we're even. And I'll just go and equals that. Else must be odd. I'll put a space to make it the same length. I'll put an end so that it all prints on the same line. And let's run that. And we go even, odd, 0, 1, 2. So there we go. That's done the challenge. So let's look at a different way of doing that. Introducing the enumerate function. So this is one of the built-in functions, enumerate. So I want to, if I put in there a list or a tuple or something iterable, when I enumerate it, it will return not only the value of each time it goes through it, it'll also give me an index in there as well. And so I can store that index in I. And so I can put two values here as the variable names in my for statement. And so because enumerate generates two values each time it goes through, one it gets stored in I and the other one gets stored in value, then I can do that same bit of code. So now I haven't had to type 0, 1, 2, 3, 4, 5, 6, 7 all the way up to 20, because I can just say enumerate numbers, and that'll give me all the values in numbers, but also give me an index to those numbers, which I need in this case because I want to work out whether it's even or odd. And then I don't need to refer to numbers square brackets I because the value's already been stored. That's the string value, has already been stored into variable called value, and then I can print it out. And I've put in a little bit of formatting here. So I said I want my I to be 3 characters wide, and I want my value to be 15 characters wide, and then show the category. So just some more things you can do with f-strings. And you can see how they all line up nicely now because I've put those column widths in there. I've got my integers are right aligned, which is the way we like to see them, and it's worked out. It's an integer, I is an integer, so if I give it a width, then I probably want to be right aligned. Meanwhile, strings are by default left aligned, and you can change that around using other formatting symbols in f-strings. Alright, so there's a good bit of code. Problem with this code is it doesn't scale very well. Like we could make a tuple with 100 elements for the numbers 0 to 99, or we could have 2 tuples, one for the first 20 numbers and one for the tens. So the tens are going to be like 20, 30, 40, 50, and so on. Alright, so if I had a value I equals 30, I want to come into my tens list and pull out this one. So I've got to do a little bit of math here. I've got to say I integer division 10 to give 3, and then subtract 2 from that because I actually want this is number 1 in my tuple list. So I'm starting to get some code here which doesn't actually read that well. It works, so like if I say tens of that index, I will get 30, and if I change that to 40 and run it again, I'll get 40. So it works, but it's not particularly clear, and that's where bugs can creep into your code. So what's another way of doing that? And this is where we can use a dictionary or a dict. And when we create a dictionary, we use curly braces rather than parentheses or square brackets as we have before. And then each value in our dictionary has a key and a value. So our key can be 20, 20, and it returns 20. 30 returns 30, 40 returns 40. So now, if I want to look at I and tens of I, 40 returns FORTY. And that's pretty clear of what it's returning. So that's all good. So that's a dictionary where it's using integers for my keys. You can use other values as well. You could even use floats. You can use strings. In fact, one of the things that the requirement for a key is that it has to be immutable. So you could actually use a tuple as a key in a dictionary, but you couldn't use a list. Alright, so here's one where I'm using strings or just characters for my keys, and it's for the phonetic alphabet. So we could use this if we wanted to spell out any words using the phonetic alphabet. So let's run that to see how it comes. So I'm taking the word Python, and it comes out as Papa, Yankee, Tango, Hotel, Oscar, November. And the way we've done that, we've got our iterating variable letter, and we've looped through. Now word is in fact, it's not even a list or a tuple, it's a string. But you can iterate over letters in a string as well as you can lists and tuples. So for letter in word, print, and then I just use indexing the same way as we've indexed tuples and lists, but just with the letter, which is the key, and it looks it up, it does a lookup, and prints it. And I've said put a space at the end of each print statement so, so that it all happens on the same line. So if I could change that to machine learning and run that, and we've got a problem. The problem is there is no phonetic for space. So let's just take the space out, and there we go. We've converted it all to phonetic. Alright, challenge 5. Write a Python script to write a number in words for any number between 0 and 99. Consider the following conditions: number is less than or equal to 20, number is greater than 20, and divisible by 10, number is greater than 20 and not divisible by 10. Okay, so let's pick a number equals 60. Alright, now our first condition is number less than 20. If I is less than or equal to 20, and you see how in Python we do less than or equal as a less than sign followed by an equal sign. Even though there's a Unicode character for less than or equal, Python doesn't use it. It uses the ASCII characters for operators. So if I is less than 20, we want to print numbers I, else if I is divisible by 10, print tens of I, else print too hard for now. Okay, so let's run that. So I gave it 60 and it returned 60, so that looked good. Let's try a different number. 13, that looks good. 30, very good. 37, too hard. All right. So let's have a look at the solution for how to what to do if it's not divisible by 10. So you can see what we've done here. We've got if I is less than the length of numbers. So that's another way of doing it. We're going to look up numbers. So why don't we just compare I to the length of numbers? So if someone's put more numbers in there, we can use them. If they haven't put enough numbers in there, then we won't get an error trying to index it. And we do less than rather than less than or equals, because in this case we've got the numbers 0 to 20, which is actually 21 items. See, it says 21 items. So that's how you would do a range check if you wanted to. So print I and numbers I, that works. Tens I, that works. And if you wanted to do a longer, we have to combine them. So we have to find out what the units are. So we do the modulo 10, and it will give you what the remainder is, which will be a number between like 1 to 9, or 0 to 9. In fact, but we know we've ruled out 0 already. And then the tens is just what's left over if you take away the ones. So we can then just display the tens, followed by a minus sign or a dash, followed by the ones. Now we're going to do that in a loop, going from 0 to 99, and I've just introduced here the range function, and that's a good way of going if you want to specify how many times you want to go through the loop. And it'll first time through it'll be 0, and it'll go all the way up to 99, so it'll go up to but not including 100. So let's run that, and we'll see, look at the numbers. 30 looks good, 30-1, 30-2, so they all look good. So just a few lines of code. We've written a function that will calculate the name of a number between 0 and 99 inclusive. And if you look back at some of my older sessions on this, we did we added in powers of 10, so hundreds, thousands, up to millions, billions, which was interesting, but it gets a little bit more confusing in this code. All right, so I've got we talked about unpacking lists and tuples before, passing them to a function. In fact, we did the print function. So we can also do a similar thing with dicts. But first of all, I'll just show you some features of the print function. We've seen you can specify a keyword argument end to say what you want at the end, whether you want a new line, or something else. And here I've got a new line, then a few equal signs, and another new line. There's also one for separator. I want to separate them rather than with a space, which is the default. I want to separate them with dash plus dash. And these are the values that I want to display. So if I ran that, I get 3, 2, 1, each one separated with dash plus dash, and then after the end I got a new line, a bunch of equal signs, and then another new line, and that's the print statement. So I could, all these named arguments you can supply using a dictionary, and the way you do that is you create a dictionary. I've called one KWArgs for keyword arguments, and I've said my end is I want to have a value, and I've done new line underscores new line, and my separator is pipe dash pipe. And because they're keyword arguments in a function, you can put them in any order you like. It doesn't matter, because they go by name rather than position. So if I run this, and to unpack it, rather than using the single star operator for unpacking lists and tuples, you can use the double star operator for unpacking dictionaries. So if I run that, we see it's put pipe dash pipe as the separator between the numbers, and at the end it's done new line underscores new line. So probably at first it's just good to know that this exists, so that when you're looking at someone else's code you can understand what it is. But some of the advantages of this sort of thing are you can set up parameters somewhere else in your program well before you call a function, and then when you call a function you just throw in star keyword args, and it or whatever your dictionary name is, and rather than having to type each value, and there could be a lot of values as well, like you might have 20 keyword arguments in there, and so it becomes quite cumbersome code calling a function that way. Some other cases I've found, like I've had a conditional where the result of some test that I've done determines whether I want to provide a particular argument or not. And I don't like having two branches of code, so an if statement creates two branches, but each of them calling the same function, because I find one thing that can happen is that you can go back and change a function in the future, but if you only change it in one spot and you don't see that it's in the other branch as well, then your code gets a bug in it. So by building the dictionary of arguments in your branches and then calling the function in one spot removes the potential for that sort of bug. Another thing is sometimes you want to pass arguments to one function, which then will send those arguments on to another function. So it doesn't need to know all the functions of the inner function. The outer function doesn't need to know the inner function parameters, because it can just catch them all into a dictionary. It can use, there's a packing operator as well as an unpacking operator, which is actually the same thing, star when you're inside your function definition. And it can just pass them all on to the other function and only look at the ones that it needs to know. So there's some of the advantages of using packing and unpacking in dictionaries. So I hope that's been useful for you. I didn't get a lot of questions tonight, but these data types are very, very powerful for handling lots of data, and so I hope this has been a good introduction for them. Okay, remember next week is a public holiday, and the week after that is our in-person session in Amazon and the Brisbane City, and the planned topics, we're going to have Slade is going to talk about MicroPython, which should be really interesting, and how to use them in microcontrollers. And then our second speaker is going to be Arun, because Bogdan couldn't make it. and but he'll have a topic on large language models and probably Anthropic. So I hope to see you in Brisbane on the 21st. That's all from me.